Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Nurhuria binti Abdul Alim. My student ID is 2018425484 and my supervisor is Professor Nuraini binti Wahab. For my FYP project, my title is Investigation on the Influence of Starch Type on the Properties of Porous 17,4 pH Stainless Steel. Now, let's move on to the introduction. Metal forms are created by a variety of novel processing techniques. Metal forms such as stainless steel and titanium with high melting temperature have been developed using the space holder and sintering technique. For biomedical implant application, metal forms are novel biomaterials. Space holder materials is used in order to bulk the pores in the implant. The content of the space holder is used to serve as the former pores and can be removed by water leaching and sintering technique. The literature review of this project are: first, porous metal. Porous metal can be divided into closed porous and open porous structure. The material with relatively low porosity, 0 to 30%, have gained the most interest in powder metallurgy. Next is metal injection molding (MIM). Metal injection molding is a method producing a net shape without any mechanical cutting and polishing. It uses a high injection pressure to ensure that the component can maintain the geometry during the process. Metal injection molding process form is the key challenge. How the porous structure create a control pore size and porosity. Lastly is space holder. In this project, I am using rice structure and cone structure. For the rice structure, it was hydrolyzed by a mixture of glucoamylase and amylase to obtain porous starch as final product. As for cornstarch, it was prepared by citric acid with different pH value. It have more porous granules compared to other starch. The problem statement of this project are: first, stress shielding phenomena are lead to bone loss and revision surgery after implant in the joint. Second, stress protection occur when metal implants are used to heal injuries such as bone plate and screw. There are three objectives of this project. First, to fabricate porous 17,4 pH stainless steel by using metal injection molding space holder. Second, to evaluate the influence of starch type on the properties of sintered porous 17,4 pH stainless steel. And the last one is to characterize the properties of sintered porous 17,4 pH stainless steel. The scope of this project are research on 17,4 pH stainless steel that using many types of starch such as rice starch and cornstarch as a space holder. Scanning electron micrograph (SEM) is used to determine the morphology for the characterization and density of metal powders. Differential scanning calorimeter is used for the characterization of the space holder material. Thermographimetric analysis (TGA) and differential scanning calorimeter tests are performed for the characterization of the binder. This is the process flowchart of the project. Characterization of metal powder: martensitic stainless steel of the 17,4 pH grade are commonly used in the aerospace industry. The stainless steel 17,4 pH powder morphology test is conducted using the scanning electron micrograph (SEM) characterization of spaceholder materials. In this research, the spaceholder is characterized using the differential scanning calorimeter (DSC) test. This test is used to analyze the spaceholder material melting temperature. It specifies the spaceholder material onset and peak melting temperature. Characterization of binder component. Binders are characterized by using three types of tests: its melting temperature and its weight change compared with temperature. Binders used in this research are polystyrene and polyethylene. Preparation of feedstock. In this research, this feedstock contain the stainless steel 17.4 pH powder, polystyrene, and polyethylene is binder and spaceholder. The feedstock is compared based on the type of percentage of composition of spaceholder material. Injection molding process. The green part will be manufactured in this process. The feedstock will be injected into the stencil-shaped cavity mold. Sintering process. The brown component formed is the dissolution process is sintered in this phase. It is a treatment that, when exposed to the high temperature, bind the metal particle together and give the gray component its strength as the final product. Hardness. To analyze the hardness of the sintered part, the Vickers hardness test is used. In this test, in the form of the right pyramid with a square base, the diamond indenter is indented with a suitable force on the specified region of the sintered section. It measures the sloping surface area under the indentation in order to attain the hardness value of the sintered section. Scanning electron micrograph (SEM). SEM is formed to observe its morphology and the porosity of the sintered section for feedstock characterization. The sintered part is then put on the carbon tape on the sample holder. In this project, the expected result can be seen that the mechanical properties of the 17.4 pH stainless steel foam are similar to the cancellous bond. The characterization of the porous stainless steel 17.4 pH is morphology of the mechanical properties for stiffness, tensile properties, porous density, porosity, and shrinkage. Other than that, one of the anticipated results of this research is the feasibility of the effect of the spaceholder, the particular scale of the properties of sintered porous 17.4 pH stainless steel. That's all from me. Thank you.